As we saw in the previous video, if f of x is b to the x and g of x is b to the negative x, then those two functions are symmetric about the y-axis. Mirror images of each other in a sense. And it doesn't matter what b is, although obviously b has to be the same in both of these functions. 3 to the x and 3 to the negative x, 10 to the x and 10 to the negative x are pairs of functions that are symmetric about the y-axis. Now we're simply going to review what we learned in a previous chapter about transformations of functions. They work exactly the same with exponential functions. So let's just assume that c is a positive number, and we know it. Let's say we know what this function looks like, y equals b to the x. Well, what happens if you tag on a plus c at the end of it? We know that it shifts it up c units. Well, if you put a minus c at the end of it, that makes the height go down by c units. So down c units. And if we replace b with b plus c, which way does it shift it? Remember, it's kind of the opposite of what you might expect. It goes to the left c units. Left c units. And x minus c shifts it right c units. And if you take b to the x and you throw a negative sign in front of it, well, now all the values or heights of the function, if they were positive, they're now negative. And if they're negative, they're now positive. That reflects it around or about the x-axis. It's like flipping it upside down. And if you replace, well, we've already seen this one up here, b, we replace x with negative x, and it makes a mirror image around the y-axis. So this reflects it around or about the y-axis when you replace an x with negative x. All right, the last ones. If you take b to the x and you put the number c in front of it, it's going to multiply the value, the height of the function, by c. So if c is bigger than 1, it stretches it. Stretches. It's a horizontal stretch. Stretches horizontally. And you can write in by a factor of c if you want to write that in. I'm running out of room. And if c is a fraction, a small number between 0 and 1, it shrinks it horizontally. So it makes it kind of shorter. And then finally, if we replace x with c of x, then again, this is another one that you might think it's the opposite of this, but if c is a big number, if it's bigger than 1, it shrinks it. But this is, oh, sorry about that. I'm going to have to make a change here. Horizontally. These two were vertically, because it's height that's changing. Stretches it vertically, shrinks vertically. Sorry about that. So this one is vertically, this one is horizontally. If c is a fraction between 0 and 1, it stretches horizontally. And for all of those, it would be by a factor of c. Okay, now let's graph the same thing we graphed before. F of x equals 2 to the x, and I kind of already filled in some of this, but 2 to the negative 1/3 is 1/8. 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2, 2 squared is 4, 2 to the third is 8. Let's go ahead and graph that again. So we have, let me start there. That's the ordered pair 0, 1. Then I'm going to go to 1, 2. Then I'm going to go to 2, 4. Then I'm going to go to 3, 8. And then backwards it'll be -1 is a half, -2 is a fourth, and then an eighth, and so on. So let me do the same graph we did last time. Okay, I may have accidentally made it touch the x-axis. It never touches the x-axis that way. That x-axis is a horizontal asymptote. Well, rather than filling in this table, can you tell me what the graph of this looks like compared to this? Well, this should be easy. When you tack on a -2, it means lower it by 2 units. When you replace x with x plus 1, it means shift it left 1 unit. So I'm going to think f of x shifted left 1 and down 2. So one way of doing this without filling in all of these values is I can go to each one of the points that I graphed already, like this one, go left 1 and down 2. Take this one, go left 1 and down 2. Interesting that one's all going to be on both of the graphs. This one, left 1 and down 2. And with all of these, let me see, we did left 1 down 2, left 1 down 2, that one, left 1 down 2. And then you can kind of see what's going to happen. Since we're going down 2, instead of having the horizontal asymptote being the horizontal line y equals 0, the x-axis, it's going down 2 units. So our horizontal asymptote is going to be that. So I can simply follow like this. So all we did was took every point on this graph, f of x equals 2 to the x. Every point we plotted, we went to that point and we shifted left 1 down 2, left 1 down 2, left 1 down 2. So you could argue, you could state that, I actually need I need to have an arrow on this as well, that the shape of these two graphs is absolutely identical. We basically just lifted this one up, went left 1 and down 2, and we got this graph right here. So that would be g of x, 2 to the x plus 1 minus 2. So that was a simple transformation of functions.